Hey everyone, welcome back to the channel. This is Rahul. In today's video, we are solving another LeetCode problem, that is minimum operations to exceed threshold value 2. In this video, we will cover the full approach and the way the algorithm works and how to write one efficient code. Later, we will mention the complexity analysis and why this one is better than other approach. So by the end, you will know how to solve this problem confidently. So let's dive in. Here is the problem. Here you have one array, one integer array nums and an integer k. Then you can perform the following operations, like we can take two small integer from the array, then we can remove both of them, that is the two small integers. Then we can go through this calculation, min xy multiplied by 2 adding to max of xy. After this operation, we can insert the new value if it's still less than k. Now, our goal is to return the minimum number of operations that we needed to make all numbers in the array greater than or equal to k. If it's impossible, then we have to return -1. Okay, so let's go through this example. In this array, we have two smallest elements, that is 2 and 1. Once we use this formula, the answer becomes 1 into 2, that is min of 1 2 multiplied by 2 plus max of 1 2. Min of 1 2 means minimum among the 1 and 2, that is 1, that is multiplied by 2, and max of 1 2 means maximum among 1 and 2. So 1 into 2 plus 2, that is 4. And the new array will become 4 3 10 11. Again, we have to go for the next because we have two elements that is less than 10. Okay, so once we try the same thing again, the new operation will be become 3 into 2 plus 4, which will be equal to 10. So all the elements are greater than or equal to the value k. As in that case, the minimum number of operations that we required to do this is 2. That's why we are getting the output 2. I hope you understand what I meant. Now I will just give what approach I am using here. So the best way to solve this problem is by using a min-heap. In case of Java, it is the priority queue. You may get doubt like why a min-heap? Actually, it helps us efficiently access and remove the smallest two elements. Then in case of operation formula, we have to double the smaller number, which will help push values higher in fewer operation. As of all, we have to keep combining the smallest numbers until all values exceed the threshold k. Now, I will just give a brief regarding the algorithm, means what we are doing here. First of all, we have to create one min heap and add all numbers that is less than k. Then we have to go through one loop that we will give one condition like whether the heap has at least two elements. Once we get into the loop, we have to remove the two smallest numbers. Then we have to combine them using the formula. Then we have to add the result back if it's still smaller than k. At last, we have to increment the operation counter. If only one element remains and it's still below k, then we have to return -1, otherwise return the number of operations that we performed. I hope you understand what I meant. Now let's get into our code. Now you can see we have one method min operations with two inputs, one integer array nums and one integer k. First of all, I have to create one min heap, that is priority queue. Now I need to add all numbers that is less than k to our heap. For in nums we have to check the condition, that is if the number less than k, then nothing, we have to add it to our queue, add to our heap. Now we have to initialize the operation counter. So I will name it as operations with the value 0. Now we have to go through one loop where we will process the heap while it has at least two elements. So while I will give one method that is empty. So while pq dot is empty till it will the loop will work till pq is not empty. Now I have to remove the least element. So pq dot poll. Now I have to increment the operation counter. I have to check whether pq is empty or not. If it is empty, we can't do anything else. So just break here itself. Or else, if it is not the only one element remain, then we have to check for the second one in y. Whole. Now we have to combine the two numbers. So I will use the type long, new value 12 x plus y. Now we have to check if the new number is less than k, then we have to add it back to the heap. So if new value less than k, we have to add it to our heap. Then we have to give the type int new value. Once it's done, come out of the loop and return the total number of operations. Just run it. It's working. So let's again walk through the key parts of the code. First of all, the heap initialization. We add all numbers less than k to minimize unnecessary operations. Okay. Then the while loop. Here we repeatedly remove the smallest two numbers, then calculate the combined value and add it back if necessary. At last, final check. The total number of operations is returned once the threshold is met. So, why this approach work? Right. Using a min heap ensures we always combine the smallest numbers first, which minimizes the number of operations. It's efficient because each heap operation takes big of log n time. So now let's analyze the complexities. As I already told, each heap insertion and deletion takes big of log n. So we may perform these operation up to n times. So the total complexity will become big of n log n. And when it comes to space complexity, it is big of n because the heap store all numbers less than k. Let's submit it. It's almost 98%. Yeah, 99.59. So make sure to handle these edge cases also. Okay. First one, small arrays. Ensure the solution works for arrays with fewer than two elements. Second, all numbers greater than or equal to k. If all numbers are already above the threshold, no operations are needed. Right. Then third one, that is impossible case. If the last remaining number is still below k, return -1. So that's it for today's video. We covered the problem, walked through an example, explained the algorithm, and wrote the code step by step. If you found this helpful, please like, subscribe, and hit the bell for more coding tutorials. See you in next video. Till that, happy coding.